Hi, my name is Dana Beg and I live in Jakarta, Indonesia. Tropic regions including Indonesia and other countries in Southeast Asia, Australia, Africa, and South America are all areas where dengue fever, a potentially very severe virus spread by mosquitoes, is prevalent. I would like to raise awareness of this illness as it is quite common in my community and many of my classmates and friends have contracted this illness. There are 4 strains of the dengue virus that are spread by mosquitoes. When an infected mosquito bites a human, the virus enters their body and up to a week later, symptoms start occurring. There are many symptoms that accompany dengue fever. These include high fever, severe headaches, as well as nausea and vomiting. Severe joint or muscle pain whilst moving or laying down can also present itself, as well as skin rashes that usually appear 3 to 4 days after the fever. Fatigue and low energy, pain behind the eyes, and acute fever are also symptoms that become increasingly serious during dengue fever. I decided to interview my close friend, Yana Capeti, who in the last year has experienced suffering from dengue fever. When talking to Yana and hearing about how dengue fever affected her over the 2 weeks she was very sick with it gave me a different perspective to the sickness as it changed her daily routine and it opened my eyes to how difficult simple tasks became for her. Luckily, she's a very healthy and active person, so it didn't take her long as others to recover, and she hasn't contracted the illness since. Here's a video made by Eliminate Dengue, an organization based in Australia that is developing a natural method to help stop the spread.
The mosquito known as Aedes aegypti originated in Africa. Over the last 400 years, it has spread throughout all tropical regions of the world, transmitting viruses to people. We are working on a way to stop this mosquito from transmitting dengue. Our method uses naturally occurring bacteria called Wolbachia that live inside insect cells and are passed from one generation to the next through the insect's eggs. Wolbachia are found naturally in up to 60% of all the different species of insects. Insects that include fruit flies, moths, dragonflies, and butterflies. The secret to the success of Wolbachia is how it manipulates the reproduction of the insects it lives in, so to give itself an advantage. It works like this. If a male insect has Wolbachia and mates with a female that doesn't, then the eggs she lays won't hatch. If the female has Wolbachia and the male doesn't, she would lay her normal number of eggs. They would all hatch, and all offspring will carry Wolbachia. When 2 insects that both carry Wolbachia mate, the eggs will hatch, and all offspring will carry Wolbachia. Over a few generations, the number of individuals carrying Wolbachia increases rapidly until nearly all the insects within a population have the bacteria. We wanted to see if we could use Wolbachia as a way to stop dengue transmission. To do this, we first had to move Wolbachia into the mosquito so that it would grow and be passed between generations. Using microscopic needles, we took Wolbachia from the fruit fly and injected it directly into young Aedes aegypti eggs. It took us thousands and thousands of attempts, but finally, we were successful. We then took the mosquitoes that contained Wolbachia and infected them with dengue, and found something really exciting. The virus didn't grow well in the mosquito, and if it can't grow, it can't be passed between people. Our next step was to build large enclosed outdoor cages in northern Australia that we filled with local mosquitoes. We then introduced mosquitoes containing Wolbachia to see if it could spread into the cage population, and it did. We now wanted to test the method where dengue is found, but before we did this, we needed the government to examine the safety of our method and approve our trials. Then we needed to gain the support and approval of communities to release mosquitoes containing Wolbachia. With these approvals, we began our first open field trials in Australia in 2011. Wolbachia mosquitoes were released once a week for 10 weeks, and within a few months, close to 100% of the mosquitoes had Wolbachia. And years later, they still do. Ongoing trials in Australia and dengue-endemic countries are now determining the best way to deploy Wolbachia across whole cities. It is our hope that with continued success, the Wolbachia control method will protect the health of the 2.5 billion people that live in dengue transmission areas.
By raising awareness of this illness and with the hope that the Wolbachia bacteria will wipe out the dengue virus, the risk of people in high transmission regions will decrease, and eventually we hope dengue fever will cease to exist.